Okay, so yeah, the section is on travel questions. Now, travel being, we're interested in things like speed and distance and time, okay? So you may remember from your physics class or science class, speed is distance on time. So distance on time. Okay, but you may not use the equation in that form. So generally, we can rearrange this, can't we? So speed is distance on time. So we could just shorthand that as speed is distance on time. But you could change that to time is speed, distance on speed. So time is distance on speed, like that. And there could be others, but they're the two main ones that you would be interested in using. So speed is distance on time, and time is distance divided by speed. So for example, when your parents drive you to school, their speed could be 60 kilometers per hour, your average speed. Okay, so that means you could have gone 60 kilometers in 1 hour. So that basically means 60 kilometers in 1 hour. So that's another way to think of it, okay? So 60 kilometers in 1 hour. So if you drive at that speed, it will take you 1 hour to go 60 kilometers. And that's your speed, 60 kilometers per hour. So every hour, you can go 60 kilometers. So you may be driving 80 kilometers in 2 hours. Okay, so if you go 80 kilometers in 2 hours, that's 80 kilometers in 2 hours. So if we simplify that, we'll get 40 kilometers per hour. So if it takes you 2 hours to go 80 kilometers, that means your speed was 40 kilometers per hour. So they're very closely related. Your speed, distance, and time are linked, okay? So just keep that in your mind. And the one we mainly use is this one here. Time is distance on speed. This one here that we'll be using. So let's look at our question. We got a man who cycled 15 kilometers from A to B at uniform speed. So when I see that, they didn't say the speed, did they? Like when we saw the question last week about uniform width, and then we just let it equal X. So in this case, I'll just let the speed that they're talking about X. So this is initial or the first speed. Let's call this the first speed we're talking about, or the original speed. Let's call that X kilometers per hour. It looks like we're using kilometers per hour. It didn't actually say here, but this part indicates we're using kilometers per hour, not meters per second or other kind of speeds like that. So if he increased his speed by 4 kilometers, so his first speed, his initial speed was X. If you increase that by 4, that would become X plus 4, wouldn't it? Kilometers per hour. So let's call that the second speed here, or the new speed. So that's X plus 4 kilometers per hour. He would have arrived at B half an hour earlier. So we'll keep this in mind. We'll do this in a minute. So let's just go back for a minute and draw a picture of A to B. Okay, he's going A to B, and this is 15 kilometers. So this is your distance, D. Okay, so if we look at our time formula here, time is distance on speed. So in the first part, when he travels at X kilometers per hour, his time would be distance, which is 15, divided his speed, which is X. Okay, so this is the time taken in hours. This is in hours. So we need this on our mind here. And when he increases his speed, what would be his time? So his time here will be, again, 15, because he still want to go 15 kilometers. And his speed then is X plus 4. Speed goes on the denominator. So X plus 4 hours. Okay, and says if he increases his speed, he's going to arrive at be half an hour earlier. Okay, so if we subtract these two fractions here, we should get 30 minutes. So this number here is going to be the longer time, isn't it? So this is the longer time. Yes, because when you have X kilometers an hour, but when you increase your speed, the time will be shorter, isn't it? So when your father drives you faster to school, you'll get there quicker, right? So this is going to be the shorter time. So the longer time minus the shorter time will be 30 minutes, half an hour. So this should equal half. So let's write that out properly. If you're copying, you can copy now because I'll scroll up a little bit. Okay, so we're going to end up with an equation where you've got your longer time, which is 15 on X hours. So this is like time 1 minus time 2 equals a half. And this is time 1, this is time 2, like that. So we've got 15 on X minus the shorter time, which is 15 on X plus 4 equals a half. So now you've got your equation, which is in not a nice form, is it? Because it's a fractional equation. So let's look at how to solve it. So just be careful about where you put these two numbers. So this is the longer time minus the shorter time. We give a positive number. If you get these the wrong way around, this would have to be negative. Okay, so the longer time minus the shorter time will give a positive number half an hour earlier. So be careful you don't get these in the wrong position. So this one first. So the bigger number minus the smaller number, obviously will give a positive answer. So think about it that way. So now we need to solve this equation, and it's a fractional equation. And remember what to do with these. I know some of you know how to do it. Most of you can do it because I saw you did it correctly on your worksheet. So we want to get rid of these denominators. So let's multiply everything by X plus 4, and 2. So each part of the denominator here, there. So I multiply every term by that. So if I do that to this one here, the X will cancel, won't it? I should write it out. X plus 4, 2. So that X will cancel that one there. So you're going to end up with 15 times 2 times X plus 4. And then we do the same here. I won't write it in because we don't have much space. So the X plus 4 would cancel. I'll be left with 2X. So minus 15 times 2X equals, now multiply that here. The 2 will cancel. You'll have X plus 4. like that. So then we're going to get our equation. We can expand it. 2 times 15 is 30. X plus 4 minus 30x equals x squared plus 4x. So we've got 30x plus 120 minus 30x equals x squared plus 4. Okay, so your 30x and your minus 30, that will cancel out. So we'll be left with x squared plus 4x minus 120 equals 0. So you can't factorize this one. You can try, but it's not going to work because you end up with decimals. So by your quadratic formula, when you solve this equation, you'll get minus 13.14, 9.14. And this is the value of x. So because x is a speed, we don't want to have a negative speed. Velocity can be negative, but not speed. So 9.14 should be the number that we use, not the negative number. So you can cut that one there. So refer to generally the positive numbers when you do these problems here, 9.14 for this one here. So that's your original speed. So you could write it back in up in here. You have, this would be 9.14 kilometers per hour. This would have been 13.14 kilometers per hour. Just add the 4. So if you increase your speed that much, then you'll get there half an hour earlier. Okay. So think about this one. This is one's done exactly the same way, actually. So we know we're dealing with distances. So let's draw our picture first anyway. You've got 2 stations. I think it's a bus station, A to B. So just draw a picture A to B so you know where you're going. Can go in either direction, doesn't matter. A to B, and the distance is 100. So your distance is 100 kilometers. So you write that first. Okay, so remember that speed is distance on time. That's the one that I remember. And then I just change that to time is distance on speed. And that's the one we'll need here. Sometimes you'll need this one, speed is distance on time. It depends on the question. So if it's not working out for you, then maybe this is the wrong formula. You need to maybe use the speed formula instead. Okay, so let's see, if the average speed of the bus is increased. So let's have the original speed be x. So original speed is x kilometers per hour, okay? And then they're talking about the average speed increasing by 5 kilometers per hour. So for the new speed, I'll do that here. That's going to increase by 5 kilometers per hour. Okay, and then we can calculate our times now. So our time would be distance on speed, and distance is all given, and it's the same for both parts. So that's 100 on x hours. And the time when you travel at the new speed, which will be a smaller number, won't it? And that would be 100 on x plus 5, like that, hours. And here it says when you do that, your travel time will be 10 minutes less. Okay, now this is in minutes, but we're dealing with hours in the question. These problems involve hours. So if you see that, you're going to have to change this to hours. So 10 minutes out of 60 minutes will give you the fraction of hours. So this is 1/6 of an hour, which is equal to 10 minutes. So just make your minutes out of 60 minutes because there's 60 minutes in an hour. So this would be 1/6 of an hour, which is equal to 10 minutes. So we need that number. So don't use 10 in your equation down here. So when we get our equation, the difference between these two again, so this time will be the longer time because the speed is a bit slower. So the longer number, the bigger number, minus the smaller number, which is the lower time. So 100 on x plus 5 equals 1/6. Okay, so the difference between the times is 1/6 of an hour. So this is 1/6. And you can see again, we've got a fractional equation. I might give you a few minutes to try and do that yourself. So can you copy this down and see if you can solve that? All right, do that yourself and I'll help you in a minute. If you get an answer for the speed for X, you can put in the chat. I can look at your answer. So if you do get an answer for X, which is a positive number, you put in the chat screen to me and then I will tell you if it's right or wrong, okay? But I just give you a couple of minutes. So I try to solve this one. Remember to multiply every side by X plus 5 and 6. And do that everywhere, each part, here, here, and here. So I'll highlight that. Put that in here, and here, and cancel. Okay, try that for a few minutes, then I'll do it. Okay, so for this question here, let's see how we would, oh, I've got an answer. Yeah, Apikid, that's 52.33, that's correct. All right, so 52.33 will be the answer. Let's see how we get that. Okay, so we multiply in blue each part, x plus 5, 6. So if I do that, I'm not going to write it because I don't have much space. The x would cancel. You'd be left with 100, x plus 5 and 6. Okay, and then we've got minus. So multiply that in here. The x plus 5 will cancel. So we'll get 100 x 6. Okay, and when I multiply that here, the 6 would cancel. So I'll be left with x plus 5. Like that. So when we expand this, we'll get 600x and then 3,000 minus 600x equals x squared plus 5x. Like that. So then you'll see your 600 will cancel here. So we're going to end up with x squared plus 5x minus 3,000 equals 0. And by your quadratic formula, you're going to get two numbers, minus 57.33 and 52.33. So obviously the negative speed you don't want, so that one can be cut off. So your answer to X, your original speed is 52.33 kilometers per hour. So that is your original speed here, X. So you could write that as, okay, therefore original. So your original speed is 52.33 kilometers per hour. And when you increase that by 5, you'll decrease your travel time by 10 minutes. Okay, so the new speed was 5 plus that, that's 57.33 kilometers per hour. So when you increase your speed by 5 kilometers from 52 to 57, you'll decrease your travel time by 10 minutes. So that will reduce travel time by 10 minutes. Now 3 looks harder because it's actually got more steps, but it's not. It's actually more set out for you to do the problem. It's been set out in a way that will help you get your equation at the end. So let's look at our question. We got a cruise ship, which usually departs at 9 a.m. from port A to port B, which are 300 kilometers apart. If the average speed of the ship is X kilometers per hour. So let's just think about a picture of our ship going from A to B. And it says that the time's actually not relevant here. It's just telling you the time it leaves. Sometimes that will be important. It depends on the question, but not this one. So from A to B, which are 300 kilometers apart. Okay, so if the average speed of the ship is X, so let's write this out as our original speed. Which is X kilometers per hour. So your time taken, let's write our formula. Speed is distance on time. Therefore, time is distance on speed. I always do that in case I mess them up. So I write this on the side and I refer back to this here. So your time is 300 on X in hours. Okay, so find in terms of X, the usual time it takes for the ship to travel from A to B in hours. So this is done here. This is actually part A for the question. This one here. Easy enough, which is what you do basically for every question like this. On Sunday, the ship increased its average speed by 4 kilometers per hour. So he's made a new trip and then he's arrived at port B 50 minutes earlier than usual, than what he originally did. So for the new speed, so his new speed was increased by 4 kilometers an hour. So we'll write that as X plus 4 because it's related to the original speed. So that's X plus 4 kilometers per hour. So his new time, he would take 300 divided by X plus 4 hours. Okay, so in this case, this time is going to be less, isn't it? He's going quicker, so this will be the smaller number, and this will be the larger number. And here it says he arrived 50 minutes earlier than usual. Notice the unit is minutes, which means that we need to change this to hours to be consistent with hours in the question here. So 50 minutes out of 60 minutes, isn't it? 5 out of 6, that's hours. So 5, 6 hours is the difference in the travel time. So we'll need that number for our equation here. Okay, so find in terms of X the time taken for travel. Okay, so this is actually part I here. BI. That's this one here. Okay, that one there. I'm just kind of working ahead of the actual question, but that's the answer for that one. Form an equation in X and show that it can be reduced to this. Okay, so that means we need to write a new equation and simplify it to be this equation here. So we're going to have the difference between the original speed and the new speed. So our equation will be 300 on X minus the new time, which is 300 on X plus 4. And that will give you 6 hours, because these are in hours, these are in hours. This must also be in hours. So unless the question is meters per second, then we may make everything seconds instead of minutes or hours. So it depends on the question. But in this question, we're using hours. But in physics, very often we'll be using meters per second. Okay, so what you need to do there is reduce this equation down to this. Okay, I should have actually have an equal 0, shouldn't I? There should be an equal 0 there. Okay, so you try that yourself for a few minutes. So multiply everything by X plus 4, and 6, whatever is in the denominator. And then multiply that here, here, and here. All right, try that for a minute. I'll do it in a minute, but try it yourself first. So in this question, we want the speed on the Sunday. So we need X, but then you're going to need to add 4, because I want the speed on Sunday, which is X plus 4. Okay, so try that. I'll help you out a little bit because I want to show one more question before the time is gone, and that one's a bit more difficult. So if we're multiplying by this, the X would cancel out. You'll get 300, X plus 4 and 6, minus 300. The X plus 4 would cancel. You would have 6X. There. If you multiply here, the 6 will cancel. So you have 5X, X plus 4 here. So yeah, kind of a big one. So we end up with 1800X plus 7,200 minus 1800X equals 5X squared plus 20X on this side here. That's 20X. Okay, so when we simplify that, we'll end up with 5X squared plus 20X minus 7,200 equals 0. So this one here would be divided by 5, because we want to get back to this original question, the original expression in the question. So we divide all of that by 5. So then you'll end up with your X squared plus 4X minus 1440 equals 0. So that's what you need to do in this kind of problem to answer part 2. Okay, so this would be the procedure for part 2 here. Now, if you couldn't do that, you could still answer question 3, couldn't you? Because you already have the equation here. So if you can't do question 2 up here, you're still able to do 3. So if I gave you that in the test and you weren't able to do this procedure here, you can still do part 3. because it says solve this equation, which is this one here anyway, and then you find your time or your speed. Okay, so we'll end up with doing 3 here. So we had x squared plus 4x minus 1440 equals 0. So just by your quadratic formula, you'll end up with 36 and minus 40. So obviously we want the positive time. So we use this one here. So your original speed was 36 kilometers an hour. So original speed equals 36 kilometers per hour. But the question wants the speed on Sunday when he increased the speed. So this would be 40. You need to add 4. So speed on Sunday is 40 kilometers per hour. So that's your answer, actually. That's your answer to the question. You'll still get most of the marks if you give the original, but I want the speed on Sunday. So you have to add 4 to that one. Now this one's actually kind of tricky. So we're in a boat. So imagine you're in a boat. And this is the river. Actually, this is like a cross section. So this is a river. I made it going down. This is actually the upstream. So if you go upstream, you'll be going this way. If you go downstream, you're going this way. So maybe there's the ocean down here. This is the ocean. And when you swim, imagine you go to the river now and swim in the river. And you swim down to the ocean. You're going to go really fast, aren't you? Because the water is all moving downstream at the moment because we've got lots of rain upstream in the river basin. So there's a lot of rain up here. So the water's moving down fairly quickly. So this is going downstream. Downstream being at the river, so going downstream means going down. So if you swim downstream, you're going to go really fast, aren't you? So, but if you try to swim the opposite direction and swim upstream, with all the water that's moving down, you're going to slow down, aren't you? So this is going to increase your speed. Increase your swimming speed. Or if you're in a boat, it's the same. This swimming we can understand because most of you know how to swim, I hope. Increase your swimming speed. If you can't swim, just pretend you can swim. So we'll swim downstream and your speed will increase because the water's all pushing you down, isn't it? But when you try to swim upstream, you're fighting against the current. The current is the movement of the water. So if you try to swim upstream, this is going to decrease your speed. It's going to slow you down. Decrease your swimming speed. It's the same with the boat. If you're in a boat, and this question is about boats, by the way, not swimming, but if you're in a boat and you just turn the engine off, you're going to go downstream, aren't you? That's the speed of the current. Okay, so you may be doing, say, 2 kilometers per hour, just because the water is moving you downstream. Okay, it's pushing you down. If you want to go up, you've got to turn the boat around and put the engine on because you won't get up to the top of the river at all because the water's trying to push you down. Okay, so this is some ideas here. And also speed is distance on time. Time is distance on speed here. So we'll keep that in our mind again. So the speed of the boat in still waters. So when the water's not moving, you can go 12 kilometers per hour, okay? But when you go downstream, it's going to be more than this, isn't it? So what we do here, we set this current of the river. What is the current of the river? The speed of the river. Let's call that X kilometers per hour. It could be 2, 3, or 4. The water is moving downstream, okay, at X kilometers per hour. So if you're trying to swim here going down, you're going to increase your speed, aren't you? So this is going to be X plus 12 kilometers per hour. So it's going to be your speed plus the speed of the river, okay? But when you're going up, you're going to slow down. It's going to be 12 minus X. Right? So if you can go 12 kilometers an hour when the water's not moving, when you go down, you're going to increase your speed by X. But when you try to go upstream, you're going to slow down, aren't you? So it's 12 minus the speed of the river. So if the speed of the river is 2, for example, imagine X is 2 kilometers per hour. So going downstream, you'll be doing 14 kilometers per hour. But if you go up, you'll only be doing 10 kilometers per hour, 12 minus 2 and 12 plus 2. So obviously you're going to go faster when you're going downstream. So that is just a concept you need to try and understand why these are like this, okay? But you can take notes of this picture here. Okay, so, and here it says we travel 18 kilometers upstream. So let's do the upstream. We're going to go 18 kilometers. What will be our time? 18 kilometers. Upstream, it would, speed is 12 minus X here. So this is our time in hours. We'll clean that out. We don't need that there. So 18 on 12 minus X for going upstream. This is the time. What about downstream? We can call that T2 if you like. So when we go downstream, we're going to go 40 kilometers. So the distance is not the same now. So downstream, we're going to go 40 kilometers. And our speed will be X plus 12 now, because we're going down, the speed is picking up because of the current is pushing us downstream. So that's 12 plus X. Okay. And now it says the total time is 4 hours, 40 minutes. So you've gone 18 kilometers upstream, turn around, and 40 kilometers downstream in 4 hours, 40 minutes. Now that is 14 on 3 hours. So that needs to be converted fully to hours. We convert the 40 minutes to 40 on 60. So 4 and 40 on 60, which is 4 and 2/3, which is 14 on 3. That's how I get my hours from this here. Because of the minutes, we need to convert that fully to hours. So 14 on 3 there. So we're going to end up with an equation where we add them. So 18, 12 minus X, plus 40, 12 plus X equals 14 on 3. Again, we have a fractional equation here. So you can try to solve that. We only have a few minutes, so I will just briefly give you the final. And we wanted the speed, the current speed of the river X. You actually get 2 answers here. You'll get 2 positive answers, but the correct one is, I think, is 3. So when you solve this equation, Well, when you simplify it, you'll get 14x squared minus 66x plus 72 equals 0. And you know how to solve these. You can use the quadratic formula. We'll get x is 12 on 7 and 3 for this one. So I took the correct answer to be 3 for this one here. So you'll get 2 positive answers. You can probably double check if the 12 on 7 is correct, but I found that 3 is the correct solution here. So that means that that's your speed, the current of the river. So current of the river. .3 kilometers per hour there. So that means if it's 3, so 12 minus 3 would be 9. So going upstream, you'll go 9 kilometers an hour. Okay, for that one there. And going downstream, you add 3 kilometers per hour. So you'll be going 15 kilometers per hour. So because obviously the water is pushing you down faster. But for the 12 on 7, I would need to double check if this works with this problem here. And why this one may or may not be correct. So don't worry about that anyway, but if you get through most of that, you get most of the marks anyway. We just take the whole number as the final answer. But I'll work on this one and I'll double check this one to see if this works as well. And I'll let you know later on.